Welcome to Foundation Mathematics, Essential Background 1, the Laws of Indices. The objectives for this session are to understand the laws of indices and apply these laws to algebraic expressions to simplify them. We begin with some notation. Here's x raised to the power y. In this example, x is called the base, and y is known as the index, power, or exponent. Laws of indices can be used to simplify powers of the same base. So a to the m times a to the n is equal to a to the power m plus n, and similarly for the other three laws. Let's have a look at an example. Simplify 3 to the power 5 times 3 to the power 6. Since we are multiplying two numbers with indices, we will be using the law highlighted on the screen. And since we are using the same base, we must add the indices, as shown. So we have 3 raised to the power 5 multiplied by 3 raised to the power 6 equals 3 raised to the power 11. Let's take a look at another example. Simplify 4 to the power 8 divided by 4 to the power 3. Since we are dividing two numbers with indices, we will be using the law highlighted on the screen. And again, since we are using the same base, we must subtract the indices, as shown. So we have 4 raised to the power 8 divided by 4 raised to the power 3 equals 4 raised to the power 5. And let's have a look at another example. Simplify 5 to the power 2 raised to the power 3. For this example, we use the law highlighted. We now multiply the powers as shown to give us 5 raised to the power 6. Now let's have a go at this example. xy all raised to the power 5. So using the highlighted law gives us xy all raised to the power 5 is equal to x to the power 5 times y to the power 5. Now let's have a go at another set of examples which are a bit more involved. We will first consider the solution to example 1a. As all the numbers and letters are multiplied by one another and order does not matter in multiplication, we can separate the numbers on one side and letters on the other, as shown. Simplifying 3 times 4 gives us 12. We will now use the first highlighted law to help us solve a cubed times a to the 4. So adding the indices gives us a to the power 7. And overall we have 12a to the power 7. We now simplify example 1b. We have the numerator and the denominator. We can cancel, so 25 divided by 5 gives us 5. And using the second law, we can subtract the indices as shown. To give us 5b cubed. And now for example 1c. Using the third law, we multiply the indices as shown to give us c to the power 8. Rearrange so that the figures are all at the front of the equation. In this case, this is only 3. Now use the highlighted law to simplify the rest of the equation to give us 3c to the power 11. We now attempt example 1d. Solve the first part of the equation using the law highlighted. So 5d cubed all raised to the power 4 equals 5 to the power 4 times d cubed to the power 4. Now using the third law, we have d cubed raised to the power 4 equals d to the power 12, as shown. And now using this highlighted law, we subtract the indices to obtain d to the 9, which gives us 625 times d to the power 9. As shown. Now let's have a look at some more involved examples. We are required to expand and simplify the expressions shown. Pause the video and have a go before proceeding. Press play when you are ready to view the solutions. We begin with example 2a. Expanding gives us the expression shown. So minus 5x times 8x and minus 5x times minus 2. Simplifying to minus 40x squared plus 10x. Now let's solve example 2b. Expanding gives us the expression shown. And tidying up, and now applying the first law of indices. So we add the 3 and the 4 as shown to give us 7, to give us 2y cubed minus 3y to the power 7. Now let's solve example 2c. So expanding, and then tidying up, and now applying the first law of indices to add the indices as shown, and for the second term, and for the final term. Now present the equation in descending powers of x. So x to the 4, x cubed, x squared. We now solve example 2d. So expand the first term and the second term. And now for the second term, as shown. And tidying up, and finally tidying up some more. So 8x minus 6x is equal to 2x. And here's our expression. Now let's practice some simplifications. Pause the video and have a go before proceeding. Press play when you are ready to view the solutions. So let's solve example 3a. First divide each term in the numerator by the denominator. X cubed divided by x squared, and x to the 5 divided by x squared. And then using the second law of indices, subtract the indices here, 3 minus 2, and here, 5 minus 2. And then tidying up, gives us x plus x cubed, as shown. And now for example 3b. Again, divide each term in the numerator by the denominator. And then using the second law of indices, 2 minus 1 here, and 7 minus 1 here. And tidying up some more, gives us 5/3 x plus 2x to the 6. And finally, for example 3c. Again, divide each term in the numerator by the denominator, as shown. And using the second law, 8 minus 2 and 3 minus 2. We have x to the 6 here and x here, which gives us 4x to the 6 plus 3x, as shown. Indices can be negative or fractional numbers. So for example, the value 1/3 is an index in the following expression. This simplifies to x to the power 1/3 plus 1/3 plus 1/3. And of course this equals x to the power 1, which equals x. Similarly, the value 1/n is an index in the following expression. X to the 1/n n times, multiplied by one another. This equals x to the power 1/n added n times, which equals x to the power 1, which is of course x. The laws of indices can be linked with any rational power. The key laws have been highlighted on your screen. Let's take a look at some notation. A number is rational if it can be written as a/b, where a and b are integers. Remember that integers are whole numbers. They could be positive or negative. Now a to the power 1/2 is the positive square root of a and is denoted as shown on your screen. So for example, 25 to the power 1/2 equals the square root of 25, which equals 5. However, 25 to the power 1/2 is not equal to -5. Now let's simplify x to the power 5 divided by x to the -3. We can convert the denominator into a numerator by multiplying the index by minus, as shown. So we have x to the 5 minus -3. Of course, 5 minus -3 is 5 plus 3, and this equals x to the power 8. Now for the next example, simplify x to the 1/3 times x to the 5/3. We can simply add the indices as the base is the same. So we have x to the 1/3 plus 5/3, which equals x to the 6/3, which is of course equal to x to the power 2. Now for the next example, simplify x to the power 5 all raised to the power 3/5. We can multiply 5 by 3/5 to give us x to the power 3. And now for example 6, simplify the expression shown. So let's rearrange so that we can see the numbers as a fraction, 3/7 as shown, and then proceed to deal with the indices of the common base. So as we're dividing, we need to subtract the indices. So 2.5 minus 0.75. And that of course equals 2.5 plus 0.75, which is equal to x to the power 3.25. Now let's simplify the expression shown. We can raise the contents of the cube root to 1/3. So now we have 8 to the power 1/3 times x to the 12 to the power 1/3. And of course tidying up. And here we can multiply the powers and tidy up some more. And of course x to the 12 times 1/3 is x to the 4. Which gives us a nice neat solution of 2x to the power 4. Now for the next example, simplify the expression shown. Now split up the fractions. So 3x to the 4 over x to the 7 minus x squared over x to the 7. Next, tidy up the indices. So we have 4 minus 7 in one and 2 minus 7 in the other, to give us 3x to the minus 3 minus x to the power minus 5. And we can rewrite this as 3 over x to the 3 minus 1 over x to the 5. Now for the next example, evaluate 16 to the power half. We can rewrite this as the square root of 16, which equals plus 4. Now evaluate 125 raised to the power 1/3. This is the cube root of 125, which equals 5. And 81 to the power 3/2, which can be rewritten as the square root of 81 raised to the power 3, which equals 9 all cubed, which is 729. And now 9 to the power minus 5/2. So let's do this in parts and break it down. This is equivalent to 1 over 9 to the power 5/2. We've simply removed the minus sign and put the 9 to the 5/2 in the denominator. This is a square root of 9, all raised to the 5. So the square root of 9 is 3, and 3 to the power 5 is 243. So overall, 9 to the power minus 5/2 is 1 over 243. And now for the next example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's examine this example. We have that y equals 1 over 125 times x cubed, and we're required to express y to the power 1/3 in the form c times x to the power m, where c and m are constants. Now y to the 1/3 can be rewritten as shown. This gives us the expression on the screen. We've used the law ab to the power n equals a to the power n times b to the power n. We can simplify the constant first, so cube root of the whole expression, and in particular we're cube rooting 125. The cube root of 1 in the numerator is of course 1. And of course, x cubed raised to the power 1 over 3, we simply multiply the powers to give x to the power 1, because 3 times a third is 1. And then we simplify in the next step 1 over the cube root of 125 to give us 1 over 5. So overall, we have that y to the 1/3 is 1 over 5 times x. Now express 5y to the minus 1 in the form c times x to the power m, where c and m are constants. So again, if we're trying to simplify 5y to the minus 1, we replace y with the expression that was assigned to it, i.e. 1 over 125 times x cubed. So recall that ab to the power n is a to the n times b to the n, and this is the law we've applied here. We start to simplify now. 1 over 125 raised to the power minus 1 is of course flipped over, so we get 125. And then x cubed to the power minus 1, we simply multiply the powers, 3 times minus 1, and then tidy up 5 times 125, and of course leave x to the minus 3 as it is, giving us an overall expression of 625 times x to the minus 3. So this brings us to the end of this session. If you have understood its contents, you should be able to understand that the laws of indices can be linked with any rational power, and also manipulate the laws shown on your screen. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to it.